In the last video, I had discussed the method of obtaining the tangent plane to a sphere. This is in continuation of that. The video had suddenly broken off. So the last bit which I had wanted to do was left out. So I will quickly revise as to the calculations which I had done last time and then continue from there to complete this part. So if S equal to 0 is the sphere, and if Q is the point x0, y0, z0, and we are interested in finding the tangent plane to the sphere at this particular point, when you write S equal to 0, S stood for x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d. That was our sphere, and so minus u minus v minus w is the center of the sphere. Of course, with the condition that u square plus v square plus w square minus d should be greater than or equal to 0. That is the radius. We had taken an arbitrary point x, y, z on the tangent plane, and this angle happened to be 90 degrees. And from this, looking at the direction ratios of the line PQ and CQ, C being the center of the sphere, we had written down the following expression, the following equation: x minus x0 into x0 plus u plus y minus y0 into y0 plus v plus z minus z0, z0 plus w equal to 0. So what are we doing? The first factor, x minus x0, y minus y0, z minus z0, are proportional to the drs of the line passing through P and Q. The second factor, x0 plus u, y0 plus v, z0 plus w, are the numbers which are proportional to the drs of the line CQ. x0 minus of minus u is x0 plus u, and so on. So I was trying to simplify and rewrite this, and except for some signs, I will continue doing some calculations with the help of this equation. So I had written x0 square plus y0 square plus z0 square. So take this term, this and this, this and this, this and this, and take it on the other side of the equation. And then you can look at minus x0 u minus y0 v minus z0 w, take it on the other side. All right. And leave the rest of the things on the other side. This is equal to x into x naught plus u plus y into y naught plus v plus z into z naught plus w. And from this equation I will do some manipulations. The manipulations are basically very simple. I add one term x naught plus u on the left hand side and the right hand side. Similarly, I take this term and add it on the left hand side and the right hand side, and similarly with this, and I added d on both the sides. Okay, so what I get is x naught square plus y naught square plus z naught square plus twice u x naught plus twice v y naught plus twice w z naught plus d is equal to x naught plus y naught plus z naught. All right. And I have x, maybe I could let me just continue, plus x times u plus x naught u, I had added this on both the sides, plus yv plus y naught v plus zw plus z naught w plus d. Okay. Why am I doing all this? See, we have already got the equation of the tangent plane. If you look at this expression, it is already, you can reduce this to the standard form of the plane, namely ax plus by plus cz plus d equal to 0. So x into this, so this is your ax plus by plus cz, and rest of the things are the constants which will constitute d. You've already got the equation of the tangent plane. What am I trying to do? I'm doing some simplifications, and after the simplification I will make a remark, and the remark will be that if you know the equation of the sphere, you can write down the equation of the tangent plane in a very, very mechanical way without having to work out all this detail, and that is what I'm trying to do. All right. So first note that the quantity that you see over here is 0. Why? Because x naught, y naught, z naught is a point on the sphere, and therefore it satisfies the equation of the sphere. Therefore the expression on the left hand side here is 0. Okay. And therefore the equation over here can be written as x naught plus y naught plus z naught plus x naught u plus y naught v plus z naught w plus d equal to 0. Okay. And observe that okay, so let me write down s equal to 0 first. This is x into x plus y into y plus z into z plus 2ux, which I can write as ux plus ux plus vy plus vy plus wz plus wz plus d equal to 0. All right. So once you know the equation of the sphere, this expression can be written, this equation can be written down in a very, very mechanical way. So look at this and look at this. You can get this from this by replacing this x by x naught. Similarly, replace this y by y naught. Replace this z by z naught. This was the term 2 times ux, which I have split as ux plus ux. Take one of them and replace x by x naught. Similarly, with this bracket, replace y by y naught and z by z naught. And what you have got is the equation of the tangent plane. Okay, so that's all about the equation of the tangent plane. Now I will quickly discuss the tangent line. So I have the sphere s equal to 0 and I fix a point q x naught, y naught, z naught, and I want to find the tangent line at this particular point. What will be the definition of a tangent line? A line which touches the sphere at this particular point. A line which meets the sphere exactly at this point. Now, how many such lines are there? There's no unique line. In fact, if we look at the tangent plane, any line lying in the tangent plane and passing through Q is a tangent line. And if you want to pick a unique tangent line, then one needs to supply some additional information. So if, for example, if this is your center and this is the point Q, the tangent line has to be perpendicular to this. So if someone gives you a direction perpendicular to CQ, then you can go ahead and find the equation of the tangent line. So nothing more about tangent lines, except that I will discuss how to find the length of the tangent line from a point outside the sphere. Okay, so I have a sphere and there's a point outside. Let me call this point as Q x naught, y naught, z naught. I want to find the length of the tangent from Q onto the sphere. Let us say that this is one such tangent line. It touches the sphere at the point P. I want to find PQ. Now, through this point Q, I mean, if you just look at this diagram and imagine what's happening, this is not the only tangent line. There are so many tangent lines through this point Q. There's another one, P dash. So there are infinitely many tangent lines. That is the, that is what is coming out from this diagram. Now the question is, will the two distances PQ and P dash Q be the same? That I will leave it to you to figure out. So right now I'm going to be interested in just finding this PQ. The idea is very simple. C is the center. Equation of the sphere is S equal to 0. And the coordinates of C are minus U, minus V, minus W. This is the radius R. What you have here is a right angled triangle where CQ is the hypotenuse. And therefore you can use Pythagoras theorem and you will get PQ square equal to CQ square minus R square. So now CQ can be obtained from by using the distance formula. So what I have over here is okay. So I think that's easy. PQ is equal to square root of CQ square, which will be x naught plus U square plus y naught plus v square plus z naught plus w square minus r square raised to 1 by 2. Let us substitute the value of r in terms of the coefficients that appear in the equation s equal to 0 and try to see if we can simplify this. Now, what is r? So s equal to 0 is the equation x square plus y square plus z square plus 2ux plus 2by plus 2wz plus d equal to 0, and u square plus v square plus w square minus d is r square. All right. So minus r square is minus of this, minus of this, minus of this, and a plus over here. So what I do is I add and subtract a d, and what I get is x naught square plus y naught square plus z naught square plus twice u x naught plus twice v y naught plus twice w z naught plus d. Okay, that's what I get. raised to 1 by 2. Now that's something interesting. That's something interesting, and therefore if you know the equation of the sphere, you can find the length of the tangent from a point outside in a very simple way. Just replace x by x naught, y by y naught, z by z naught. Namely, substitute the coordinates of q into the equation of the sphere and take the square root. What you get is the length of the tangent. That's all in this video. Thank you.